Hi, I'm going to help you figure out how to find the area of different trapezoids today. I have 4 examples for you. Each one's a little bit different, so watch the whole video so you can learn a variety of strategies. This first trapezoid we're going to treat as a composite shape. And if you study the trapezoid, I bet you've already noticed that there is a rectangle, this green rectangle, and a right triangle, this blue right triangle. And those two figures together make the same area as the trapezoid. So to find the area of the trapezoid, we just need to add the triangle to the rectangle. So in order to do that, we have to know the base and the height of each. And the height of both of these, if you look at this, you can see that the height is always where there's a square angle. And so there's a square angle right there. And so we know the height of the triangle is 6. And it's also the same square angle on a rectangle, because a rectangle has 4 square angles. So the height of both of those figures is 6 centimeters. And the base of the rectangle is 5 centimeters, because that's the distance up here and the distance down here. But what we don't know is the base of this triangle. So that's the thing that we have to figure out in order to find the area of the whole trapezoid. So we have to study the original figure. And if we look at the base up here of 5 and bring it down here, that 5 is the distance from the left side of the rectangle to the right side of the rectangle, where the 7 is the distance from the left side of the trapezoid to the right side of the trapezoid. So if I just subtract the 5 from the 7, I get 2 centimeters. And those 2 centimeters tell me the base length of this triangle. Now I have all the information I need to find the area of each of these figures. So the area of the rectangle is the easiest. We can do that first. Base times height is 5 times 6, or 30 centimeters squared. The area of the triangle is 2 times 6. We have to divide it by 2, because when you find triangle area, you always multiply the base and height and divide by 2. So that's 12 divided by 2, or 6 centimeters squared. So the area of the trapezoid is this 6 centimeters squared plus that 30 centimeters squared. And altogether, we get 36 centimeters squared. So that's probably our easiest example. Let's take a look at the next one. This trapezoid, this is called an isosceles trapezoid because the 2 sides that are not parallel are equal. And isosceles means there's 2 equal sides. So if you study this trapezoid, we can also treat it like a composite area problem. And I bet you've noticed that there's a rectangle with 2 triangles that are exactly the same. So for me to find the area of this trapezoid, I just need to find the area of the triangle, add it to the rectangle, and then to the other triangle. In order to find the area of each of those, I need to figure out what the base and height of each is. So this is 5 centimeters, just like the last problem. And the height of each of these is 6 centimeters. So I'll put that in the middle. And the left triangle and the right triangle are the same. So once I find the area of the left triangle, I'll know the area of the right triangle. But similar to the last problem, I don't know this value. So I have to go back to the original problem. I'm not sure if you could see that, and find that value. So when I study the original figure, I notice that this 5 is the distance from the left side of the rectangle to the right side of the rectangle. But the 9 is the distance from the left side of the trapezoid to the right side of the trapezoid. So I have to subtract the 5 from the 9, and I get 4 centimeters. I need to divide that into 2 equal parts. And when I do that, I get 2 centimeters for each of these bases. This is 2 centimeters, and this is 2 centimeters. So now I have enough information to figure out the area of the triangle and the area of the rectangle. So this triangle is 2 times 6. Because it's a triangle, when we find area, we have to divide by 2. So that's 12 divided by 2, which is 6 centimeters squared. That makes this triangle 6 centimeters squared. And the rectangle is 6 times 5, or 30 centimeters squared. So to find the area of the whole trapezoid, I add the 6 centimeters squared plus the 30 centimeters squared plus the 6 centimeters squared. When I add all 3 of those up, I find that the area of the original trapezoid is 42 centimeters squared. So that's our second example. Let's look at the third example. So this trapezoid is a little bit different. Because it's not isosceles, and we can't really break it up into a rectangle because we really don't know this distance. So one method that always works nicely is the 2 triangle method. And the 2 triangle method takes a trapezoid, and what you do is you take a line and you divide the trapezoid into 2 triangles by connecting the top vertice of one side of the trapezoid to the bottom vertice of the other. It might be a little bit difficult to see what I'm talking about, so let's put some color into this problem. There's this green triangle, and you guessed it, a blue triangle. So if I can find the area of each of those triangles, then I can find the area of the trapezoid. So I just need to add the green triangle to the blue triangle. And what I'm going to do with this blue triangle is I'm going to rotate it, because I think it's a little bit easier to think of that when it's rotated, to see where the base is. And then once I've done that, I'm going to find the values that I need to figure out the area of each triangle. So the green triangle is a little bit easier than the blue triangle. We have the height of the trapezoid here, and it's the height of both triangles. So as you can see, it fits in nicely there, and it makes that square angle. So remember, when we practice triangle area, I suggested that you always highlight the 2 parts of the triangle that form the right angle, so you know what values to use to find triangle area. And so on the green triangle, I need that whole base length of 8. And I need the height value of 6. For the blue triangle, the height is outside because it's an obtuse triangle. So an obtuse triangle is one of those triangles where it has one angle that's more than 90 degrees. But the base is still here, and if you could imagine if it did continue on, it would form a right angle with the height. So we always have to use the base of the triangle has to be one side of the triangle, and the height, when it's obtuse, is actually outside of the triangle. So you learned that back in elementary school, but there's a lot of things to remember, so it's nice to review those. So the height of that triangle is 6. In fact, the height of both triangles in a trapezoid are always the same. And then the base of that triangle, remember I rotated it, so it came from on top of the trapezoid, and that's 3.2. So for me to find the area of this whole trapezoid, I just need to find the area of the two triangles and add them together. This first one is a little bit easier than the second. I'm going to just do base times height. Eight times 6 and divide it by 2. And that's the beginning of the area. So 8 times 6, that's 48. Going to divide it by 2. So the area of that triangle is 24 centimeters squared. And then I have to add it to the area of this triangle, which is 3.2 times 6 divided by 2. So we could do a quick little scratch work over here. I'm going to do 6 times 3.2 with the area model. 6 times 3 is 18. 6 times 0.2 is 1.2. So that's equal to 19.2. And so I have 19.2 divided by 2. And when I divide 19.2 divided by 2, I get 9.6 centimeters squared. So the final area of this trapezoid is 24. Do a little more scratch work. Plus 9.6. A lot of you can do that with mental math, and that would be okay. But it's sometimes nice just to see it all worked out. So the area of this trapezoid is 33.6 centimeters squared. That's our answer for the third one. So let's have you look at this fourth one. Maybe pause the video and try it yourself. So we're going to do the two triangle method. Hopefully you've tried it by yourself. And I bet if you study this, you'll see there's two triangles here, the green one and the blue one. So as long as I can find the area of the green triangle and add it to the area of the blue triangle, I can find the area of the trapezoid. Like I did the last time, I'm going to rotate this trapezoid, or this triangle here. So it's a little bit easier to kind of think about where that base is. And in order for me to find the area of these shapes, I need to put the base in of each. So this has a base of 5. And you can see the height here is one of the sides of the triangle because that square angle fits perfectly. And the height here is one of the sides of this triangle. I had it a little lopsided, so I'm just fixing it. And because I rotated that triangle, the base of the blue triangle is 2, and the height of both of them is 6. So to figure out the area of the trapezoid, I just need to figure out the area of each triangle and add them together. So the area of the green triangle is 5 times 6 divided by 2, which is 30 divided by 2. And that is 15 centimeters squared. And the area of the blue triangle is 2 times 6 divided by 2, which is 12 divided by 2, and that is 6 centimeters squared. So the area of the trapezoid is 15 plus 6, or 21 centimeters squared. And there's 4 different examples.